Hello everyone, welcome to this video, and in this video we're going to discuss variation in mathematics. Let's understand variation. Variation, it is a relationship of two more or more variables. So we're talking about variables and in their relationship. Let's go on the kinds of variation. Technically, I have four here. First one is direct variation. Other one is inverse variation. Then we have joint variation and combined variation. Let's have the first example, which is the direct variation. It is stated that y varies directly to x. Now, we started with the formula, which is y is equal to kx. K stands for the constant, and y are the two variables that we're checking on their relationship. Now, we're getting the constant, so therefore, when deriving it, the constant will lead us to y over x. So let's have some problem. So y varies directly to x if x equal to 4 and y is equal to 12. Then what are the following? First one, we want to find now k, which is a constant. Then if x equal to 6, then what is y? If y is equal to 24, then what is x? First thing to do is, let's go solve now the constant. Now, working with the setup, we have y is equal to kx, which is this one. Then we substitute and solve for k. Now, working with the substitution, you have the given value, which is 4 and 12. So, working with 12 as y and then k and then 4. Working with that by division property of equality. So, we found out that k is equal to 3. Now, we can have now y is equal to 3x as the formula. Now, we can now solve b and c. Now, solving for b, let's have now our setup, which is our formula, y is equal to 3x. So we're solving for y, therefore, if x equal to 6, so y is equal to 3x, we substitute now the value of 6. So y is equal to 3 times 6. Then we have now 18. So the value of y if x equal to 6 is 18. Let's solve now for c. So let's have our setup, y is equal to 3x. So substituting now the value to solve for x, so y is equal to 3x. So we have 24 is equal to 3x. Dividing both hands side by 3, we find out that x equal to 8. Let's have another variation. Next is the inverse variation. So it's stated that y varies inversely to x. The formula is y is equal to k over x, where k is the constant. Now, we need to get now our constant to start with this one. So therefore, our constant would be equal to x times y. Let's have now a problem. So the problem is y varies inversely to x. If x is equal to 24 and y is equal to 2, then what are the following? First one is a constant. Second one is if x equal to 4, then what is y? Then if y is equal to 8, then what is x? Solving for the first problem, we need to look at our setup, which is y is equal to kx, as you can see, similar to this one. So working with that, we need to substitute and solve for k. So 2 is y, 24 is x. So therefore, that is our setup. Working with that, k is equal to 2 times 24. So we have now 48 as the value of our constant. So as a formula, we have now y is equal to 48 over x as a formula. Let's have now the second problem, which is if x is equal to 4, then what is y? Using now our setup, which is our formula, y is equal to 48 over x. We substitute now and solve for y. So y is equal to 48. Y is equal to 48 over x. So substituting now the value of x, which is 3. Therefore, 48 divided by 3, that is 16. So we can solve that y. If x is equal to 4, then y is equal to 16. Now another is working again with the setup, which is the problem is if y is equal to 8, then what is x? So we have now y is equal to 48 over x. Substitute and solve for x. We have now y is equal to 48 over x as our formula. Substituting 8 is equal to 48 over x. Solving for the value of x, we have 48 over 8. Then therefore, x is equal to 6. At this point, let's discuss now combined variation. It is known as combined because it combined the two variations such as the direct and the inverse variation. So given now the statement y varies directly to x and inversely to z, it will lead us to a formula which is y is equal to kx over z. So getting now the constant, the derivation will lead us to k is equal to yz over x. Now let's have an example. Y varies inversely to x and inversely to z. If x is equal to 3, y is equal to 9, and z is equal to 2, then what are the following? First one is the constant. B, if x equal to 4 and y is equal to 3, then what is x? The last one is if y is equal to 8 and z is equal to 6, then what is x? Now, let's solve now for a, which is the finding now the constant. Setting up y is equal to kx over z. Substitute and solve for k. So we substitute 9 is equal to k times 3 over 2, which is the value of x, y, and z on the given here. Solving that, k would be 9 times 2 over 3. Well, then we're going to get k is equal to 6. Now, therefore, we can now derive y is equal to 6x over z as the formula. Now, we can now solve b and c. So, let's solve now b. Our setup would be y is equal to 6x over z. Substitute and solve for z. So, we have now 3 is equal to 6 times 4 over z. Therefore, z, when deriving, z is equal to 6 times 4 over 3. Therefore, z is equal to 8. Another would be if y is equal to 8 and z is equal to 6, then what is x? So let's have now the setup. Y is equal to 6x over z. Substitute solve for x. We have y is equal to 48 over x. So 8 is equal to 48 over x. So why is it 48? Because 6 times 8. Yeah, 6 times 8, then x. So therefore, x is equal to 48 over 8. Therefore, we have now 6. Okay, let's have this joint variation. So joint variation are there are two variables with as independent variable and the dependent where they have a relationship to a dependent variable which is the same. So for example, y varies directly to x and z. So the formula will lead us to y is equal to k xz. So the xz are the independent variable and the dependent variable is y. Now getting now the constant, we have now k is equal to y over xz. So for example, y varies directly to x and z if x equal to 14 and z is equal to 3 and y is equal to 21. Then what are the following? The constant. Another problem is if x equal to 4 and y is equal to 3, then what is z? Then we have y is equal to 8 and z is equal to 6, then what is x? So let's find out the constant. So let's have now the setup, which is y is equal to k xz. Substituting now the value, 21 is equal to k times 14 times 3. So we have now k is equal to 21 over 14 over 3. So we have now k is equal to 1 half. So we can say that our formula will be y is equal to 1 half times x and z. So when using now the setup for solving now, using the problem, if x equal to 4 and y is equal to 3, then what is z? So therefore substituting that, 3 is equal to 1 half and then 4. Solving that, you have now 3 is equal to 2x and x would be equal to 3 halves. So another problem would be if y is equal to 8 and z is equal to 6, then what is x? So let's have now the setup. Y is equal to 1 half xc. Substitute and find the value of x. So 8 is equal to 1 half x times 6. So multiplying 1 half and 6, so will be 3x. So solving for x, 8 thirds. So the value of x whenever y is equal to 8 and z is equal to 6, that is 8 thirds. So let's have now the summary of the variation. The first one is a direct variation where y varies directly to x. So the formula is y is equal to kx, and the constant is k is equal to y over x. Another variation is the inverse variation where y varies inversely to x. Formula would be y is equal to k over x, and the constant would be k is equal to kxy. Another is y varies directly to x inversely to z, so therefore formula is y is equal to kx over z, and the constant would be k is equal to yz over x. And then last b, y varies directly to x and z, the formula would be y is equal to kxz, and getting now the constant would be k is equal to y over xz. And now, thank you for watching this video and this video discussing the variation from direct, inverse, joint, and combined. Hoping you've learned something with this video. Thank you very much and have a great day.